Okay, looking at verifying a trig identity. So notice we have two sides to this equation. We want to make them look the same. We want to show that this right here, cosecant squared minus 1 over cosecant squared, equals cosine squared of x. So that's what we're looking to do. All right? So the first thing that I would realize is that this side, the left side, is clearly more complicated than the right. So I'm going to try to simplify down the left side so it looks like the right side. That just seems like it makes sense to me. And I noticed that the numerator, cosecant squared x minus 1, really does remind me of a Pythagorean identity. I have some trig squared minus or plus 1. Somehow we can probably rewrite the Pythagorean identity to look like this. So I'm going to recall back my Pythagorean identity, sine squared plus cosine squared equals 1. I'm going to try to rewrite this so that I have cosecant squared. And I remember that, okay, cosecant is 1 over sine. So I'm going to divide everything by sine squared. That gives me 1 plus cotangent squared x equals cosecant squared x. Now I can see that if I just subtract 1 over here, cotangent squared x equals cosecant squared x minus 1. So I'm going to use that cotangent squared x over cosecant squared x. That's how I'm rewriting the left side. I'm going to leave the right side alone. Again, I'm going to work to try to simplify down the left side so that it looks like cosine squared x. Now I'm going to write this in terms of sines and cosines. So this is cosine squared x over sine squared x over 1 over sine squared x. You might see where this is going. A fraction divided by a fraction. I'm going to keep, change, flip. This would be cosine squared x over sine squared x. Keep, change to be multiplication, and flip this. Of course, we have sine squared x on the top and the bottom, and what do we get? We get cosine squared x left over, which of course does equal cosine squared x. We have verified that trig identity. All right, we want to verify this next trig identity, and this sure does look a little bit more complicated. We've got fraction plus a fraction over here, and once again, I'm going to recognize what is the more crazy, I guess the weirder looking side, the more unsimplified side is over here on the right. I'm going to try to simplify this down to get 2 cosecant x. So we're going to see if that works out. Now there's a lot of ways to work through this one. The book has a different explanation of this, but to me, when I see all of this cosecant and cotangent and all this stuff, it just makes it a lot easier in my brain if I go ahead and put it in sines and cosines. I understand sines and cosines better. I know sines and cosines quite often will eliminate each other, and that just makes my brain appreciate it a whole lot more. So that's what I'm going to do. I'm going to rewrite this. We know that cosecant is 1 over sine. I know that cotangent is cosine over sine. Over here I've got 1 over sine minus cosine over sine. Of course, I can simplify the denominator. Now there's a we have a common denominator in the denominator. And so we've really got, over here, we've got 1 over 1 plus cosine of x over sine of x plus 1 over 1 minus cosine of x over sine of x. Notice this is 1 divided by this fraction. That's just asking for the reciprocal of this. And so that's what's happening in both of these situations. So if I actually perform that division, aka perform that reciprocal, that's sine of x over 1 plus cosine of x plus sine of x over 1 minus cosine of x. All right. So now, again, lots of ways to do this. You might not want to work through it this way, but I notice there's a sign in the top of, in the numerator of both. I'm going to factor out that sign. So I have 1 over 1 plus cosine of x plus 1 over 1 minus cosine of x. Notice what I did? There's a sign in both. I pulled that out, factored that out, and I'm left with this. So now if I want to actually add those two fractions together, I can get a common denominator. I'm going to have to multiply the top and the bottom of this one by 1 minus cosine of x on the top and the bottom. Over here, I'm going to have to multiply this one by 1 plus cosine of x. If you've been following any of these identity videos so far, you know that when we have this situation, 1 plus cosine of x, 1 minus cosine of x, that is going to be essentially, well, those are conjugates. That is the difference of squares situation. So we have sine of x on the outside. On the top, we have 1 minus cosine of x. On the bottom, 1 minus cosine of x times 1 plus cosine of x gives us 1 minus cosine squared x. It gives us that difference of squares. Over here, 1 plus cosine of x over 1 minus cosine squared of x. Okay, so we have the common denominators. We can now add them together. We still have that sine of x on the outside. When we add across, well, I'm going to go ahead and give my common denominator there, 1 minus cosine squared x. At the top, 1 plus 1 gives me 2. Negative cosine of x plus cosine of x cancels out. That's gone. 1 minus cosine squared of x, think back to your Pythagorean identity. 1 minus cosine squared of x is just sine squared x. Still have the sine of x on the outside. Have my 2 on the top. The sine on the outside cancels out with one of our signs in the denominator. So that is 2 over sine of x. This can be written as 2 times 1 over sine of x. And what is the reciprocal of sine? What is 1 over sine of x? That is cosecant. So this is 2 cosecant x. And that's what we get way here at the beginning. Like I said, the book does it a different way. Theirs is a little bit more concise than this, but this is what makes sense to me when I see this. This is how I want to break it down. And I just go in logical steps to me. If you can see it in a different way, if you can see the same identity, if you can prove it using logical steps that are true, then you're verifying it your own way.